Let's do a practice problem. True or false? One of the characteristics of the binomial distribution is that the probability of success for each trial depends on whether the previous trial was a success or not. So please pause, think about this question and say whether it is false or true. Right, let's see if it's false or true. It is false. For example, suppose that you toss a coin n times, 10 times, for example. Does it matter if you get like 3 heads? Would it make the next tossing a more probability or more chance to get a tails instead and reduce the number of heads that you will get? No, each time that you toss a coin or repeat this experiment, the probability is going to be independent of the next or the previous tossing or repetition of experiment. Using binomial distribution in Excel. The command binom.dist, binom distribution function, calculates the probability of X number of successes from n events. So suppose that n is 10 and the probability of success is 30%. Then you can actually use Excel to find this probability. Probability for 0 success is 3%, 1 success is 12%, 2 success is 23%, 3 success is 27%, and so on and so forth. So let's see how it works. If we actually plot the figure for this, the probability distribution or the frequency distribution for this, this is what we're going to get for the binomial distribution in this example, as you see here. To do this in Excel, this is how you can do it. If you find the probability that the random variable x, which is shown by capital X here, gets a value of x shown by a small x, you need to type in this formula in Excel. Binom.dist, parentheses open. The first one is x, the number of success that you want, comma. The second one is n, the number of trials, or how many times you repeat the experiment, comma. The next one, the third parameter is p, the probability of success, and comma, the last one should be 0. The last one indicates whether you want it to be cumulative or non-cumulative. Cumulative means that, for example, if you want the probability of x and greater than x. So here you want to be exclusively equal to x. That means you don't want to be accumulative. So you will gonna put 0 that you don't want the cumulative one. If you want a cumulative, such as this one, for example, you want the probability of x less than x. That means probability that x is equal to x, x is equal to x minus 1, x is equal to x minus 2, etc., etc. So it's cumulative. It's going to add up from 0 to x. Then the parameter that you have to put for the last one is going to be 1 instead of 0 because you want the cumulative one from all the values from 0 to x. And all other parameters are the same. X is the first one, n is the second, and p, the probability of success, is the third one. You can actually try this. Just open up an Excel file and try this to see how it works. Binomial distribution characteristics. So we learned about the expected value or the weighted average or mean, as we call it, for a random variable, a discrete random variable. Also the variance of a discrete random variable. So let's see how we can actually compute. What would be the formula for if we compute the expected value of a random variable which follows in binomial distribution with n number of trials and p probability of success. So the average would be, the expected value would be n multiplied by p. N is the number of trials, the number of times that you repeat the experiment, and p is the probability of success. If you also put in the formula for finding the variance, this is what it's going to be look like. The variance would be The variance is n multiplied by p multiplied by 1 minus p. N is the number of trials, p is the probability of success, and 1 minus p is the probability of failure. And the standard deviation is just a square root of this. So n here is the numbers, the sample size, or the number of times that you repeat the experiment per se, and p is the probability of success, and n1 minus p is the probability of failure. Let's see another practice problem. The nationwide motel company has determined that 70% of all calls for motel reservations request non-smoking rooms. Recently, the customer service manager for the company randomly selected 25 calls. Assuming that the distribution of calls requesting non-smoking room is described by a binomial distribution, what is the mean and the standard deviation of requests for non-smoking room? So here the question asks for the average, the mean, and the standard deviation of requests for non-smoking room. These are the formulas for the expected value, the mean, and the standard deviation of binomial distribution. So please pause, work on this problem. You already have the formula, and then come back to see the solution. All right, let's see the solution. So here we need to define first what is the random variable x. So x is actually the number of requests for non-smoking rooms. So the number of reservation requests for, so it would be number of reservation requests call request for non-smoking room, right? Okay, so what we are looking for is the expected value of x. What is the expected value of x? We know that x here, it says it follows a binomial distribution. The number calls requesting non-smoking room described by a binomial distribution. And this is the deal, because each time that a customer calls for reservation, he or she would either ask for a non-smoking room or he does, or he would doesn't care and he want a smoking room, right? Or a smoking room, right? So it's going to be only two scenarios possible, two outcome: a smoking room, non-smoking room. There is no other way. So this is, and also we repeat this experiment by each time a new customer calls, right? So this happens again. And we are looking for the expected value. X here, the number of calls for requesting for a reservation of non-smoking room, it says follows a binomial distribution with n here equal to what? What is n here? That's the total number of trials here in the definition of binomial distribution. What is the number of trials here? It means the number of calls that we have got. So it says it's 25. So n here is 25. What is the probability of success? Meaning that the customer that calls would ask for non-smoking room. It says 70% of calls. So probability of success here, which we define it requesting for non-smoking room, is 70%. 70%. All right, so we have this now. We can find, using this formula, we can find it. So expected value of random variable x is equal to n multiplied by p. N is 25 multiplied by 70%, and we get the solution. And that is 17.5. So on average, 17.5 or 18 would request for non-smoking room. For finding the standard deviation, we use the other formula here. This is square root of n multiplied by p multiplied by 1 minus p. So let's see the solutions here. So the expected value is 17.5 and the standard deviation is 2.29. The shape of the binomial distribution. So let's see what would the histogram or the probability distribution, the shape of it, look like for a binomial distribution. So of course, binomial distribution has two parameters, apparently n, the number of trials, and p. So we would expect that the shape of the distribution would also depend on these two parameters, n and p here. If if the probability of success p is greater than 50% and n is sufficiently small, the distribution is left skewed. Sufficiently small is less than 30. So if p is greater than 50%, because the probability of success is between 0 and 1. So if it's greater than 50% and n is small, then the distribution is left skewed. It would be something like this. This is continuous, although. It would be like this. For example, right? Right. If p is exactly equal to 0.5, and for any value of n, it doesn't matter what n is. If the probability of success p is 50%, then the distribution is symmetric. The distribution is symmetric. It means that it would look like this. Again, this is not a good one. This is again continuous, so we have to make it discrete. So it would look like something like this. All right. If p is less than 0.5 and n is sufficiently small, less than 30, the distribution is right skewed. If n is very large, the distribution becomes symmetric. So no matter p is less than 50% or greater than 50%, if n is actually large enough, then you're going to get a symmetric distribution for the shape of the binomial distribution. And n here, how large or small it is subjective, but it depends also on p here. So let's see. The first one here, we have, as you see here, p is less than p is 10%, which is less than 50%, and n is 10, so n is a small, so that's why it's right skewed. So this is this scenario. This scenario, p is less than 50%, 10% less than 50%, n is a small because it's 10, so that's why we have a right skewed distribution. Let's see another example. So in this example, as you see here, it's symmetric. N is 10 and P is 50%. So that's why it's symmetric. And you shouldn't be too hard on whether it's symmetric or not. This may not exactly look like really symmetric, but we have to consider this on average. Yes, approximately this is a very good symmetric shape. Let's see a practice problem. Which of the following statements is true? A binomial distribution with n equal to 20 and p equal to 0.05 will be right skewed. B, a binomial distribution with n equal to 6 and p equal to 50% will be symmetric. C, a binomial distribution with n equal to 20 and p equal to 0.05 has an expected value equal to 1. And D, A, B, and C are all true. So please pause, try to see which one of these is correct, and then come back to see the solution. All right, let's see the solution. So let's see if A is true. A binomial distribution with n equal to 20, so n is actually pretty small. It's not really large. It's not greater than 30, and P is less than 50%. So we would expect this to be right skewed. So A actually is correct. Let's see if B is correct. A binomial distribution with n equal to 6 and P equal to 50% will be symmetric. So when P is 50%, you're going to have a symmetric shape no matter what n is. So B is also correct. A correct, B2 is correct. So that means that D must be correct, right? All right, so let's see if C is truly correct. A binomial distribution with n equal to 20 and p equal to 5% has an expected value equal to 1. The expected value for binomial distribution, if you remember, is n multiplied by p, right? N multiplied by p. So n here is 20 multiplied by 0.05, we get 1. So C is also correct. This makes D the correct solution for us. Next practice problem. Accuracy at taking orders at a drive-through restaurant is important for fast food chains. Assume that the accuracy rate for orders at Wendy's is 89%. This means that if you go to Wendy's, the probability that they get your order correct is 89%, and the probability that they would get it wrong is 1 minus 0.89%, which is 11%. If you and two of your friends order at a Wendy's drive-thru at the same time, what is the probability that A, all three orders are filled correctly? So this is a binomial distribution. You have the formula here on the right, so please pause, work on this problem, and try to figure out how to solve it and what should be the probability, and then come back to see the solution. Right, so let's see the solution. So first of all, this is a binomial distribution. Why? Because each time that a customer make an order, it have only two possibilities, whether they get their order correct or whether they get their order wrong, right? Incorrect. So there are only these two possibilities. And also this can be repeated for more customers. So if you have 10 customers, then this is going to happen 10 times, right? So you can have different outcome here. So if this is so this seems to be a binomial distribution. Now we have to figure out n here, the number of trials, and x here. So what is n here? N is the number of trials. How many times this would be repeated? So you and two of your friends go, that means that 3 orders would be ordered. So n is 3. Because there are 3 people that make an order. So this means that this experiment of getting an order repeated 3 times. The number of trials is 3, right? So, but the question asks for all of the 3 orders are filled correctly. So what does this make x for? What is x here? X is the number of success. If we define the number of success here as getting their order filled correctly, then x would be 3 here as well. So this question asks for what is the probability that x is exactly equal to 3. This is what we need to find here. So n here is 3 and x is also 3. What is p? The probability of success. It is stated here, the probability of success is 89%. So that's the probability of success. So let's find a solution here. So if you use the formula, you're going to get 0.705, about 71% chance that the 3 of you would get your order correctly fulfilled. Let's see the next part of the problem. What is the probability that none of the orders are filled correctly? You have the formula here, so please pause and work in this problem, find the probability, and then come back to see the solution. All right, let's see the solution. So here is the same problem. You and 2 of your friends have gone to Wendy's and each of you have ordered. What is the probability that none of your orders get correctly fulfilled? So here we are dealing with a binomial distribution. X, the number of orders that are successfully fulfilled, follows a binomial distribution with n equal to 3 here because you are 3 people, and p probability of success equal to 0.89. 89. Right. So here it asks for what is the probability that the number of the orders that get fulfilled correctly is equal to 0. This is what you have to look for using this formula right here. So you have to just plug in this formula. So let's see the solution here. So the probability is 0.0013, which is a very small number. So that means that there is less likely that none of you get your order fulfilled correctly. So, or it means that there is a little chance that none of you get the order filled correctly. Let's see the next part of this practice problem. So what is the probability that at least 2 of the 3 orders are filled correctly? So please pause. First, try to understand this question. What is exactly the question asked for? Try to see if you understand the question, and then you have the formula on the right and try to solve it, and then come back to see the solution. All right, let's see the solution. So here is the same problem. We have x, the random variable is the number of orders that are fulfilled correctly. It's a binomial, it follows a binomial distribution with n equal to 3 because you and 2 of your friends are 3 people. That means the number of trials is 3. The probability of success is 89%. And the question is asking for the probability that x, the number of success, is at least 2 of the 3. So that means at least 2. This means that exactly 2, the probability that exactly 2 orders get fulfilled correctly, plus the probability that 3 orders are get fulfilled correctly. So you need to find both for x equal 2 and x equal to 3 to solve this problem. So let's see the solution here. So x here, n here, the number of trials is 3, x is greater than 2, p is 89. Probability of x greater than or equal to 2 is exactly 2, exactly 3, and that's equal to, we use the formula to do it for each of these, and we get 0.9664, or about 97% approximately. So the chance that at least 2 of you get your order correctly filled is about 97%. Let's go to the next part of this problem. What are the mean and the standard deviation of the binomial distribution for the number of orders filled correctly in this problem? So we have the formula here for expected value mu and for the standard deviation. So please pause, use this formula and try to find the expected value and the standard deviation for this problem, and then come back to see the solution. All right, so let's see the solution. So here we have all the data that we have. X is a random variable following a binomial distribution with n number of trials equal to 3. So n is 3. And p probability of success is 0.89. So the expected value would be multiplication of n multiplied by p would be 3 multiplied by 0.89. And the standard deviation would be the square root of n multiplied by p multiplied by 1 minus p. So let's see how it would work. So the average, the expected value is 2.67. So on average, we could expect to have 2.67 order out of the 3 orders to get fulfilled correctly. And the standard deviation is 0.54. This problem. Suppose an increase or a decrease in the price of a stock between the beginning and the end of a trading day is an equally likely random event. What is the probability that a stock will show an increase in its closing price on 5 consecutive days? You have the formula down below. Please pause, work on this problem. First try to understand it and then solve it, and then come back to see the solution. All right, let's see the solution. So first of all, why is this a binomial distribution? As it says here, the price of a stock can go either up or down. So there is only two output, presumably, for this. And it could go either way, equally likely. So this means that the probability that it goes up is 50%, the probability it goes down is 50%. This is like an assumption. All right. So if we're considering increasing the price of a stock as success, then the probability of success is 50%. So each day that we repeat this experiment, that means we look at the price of a stock. That means that we are repeating a two outcome random event multiple times. This is like repeating of an experiment that has two output only. So this would be a good example, a good fit for binomial distribution. So what is n here? Let's define x actually first. X is of a random variable, and it stands for the number of days with an increase in a stock price. So what is n here? The question says, what is the probability that a stock will show an increase, that means a success, in its closing price on 5 consecutive days? So n actually is 5 here. We want to have success 5 times in a row. So the question actually asks for, let's first write the distribution. So x would follow a binomial distribution with n number of trials to be 5 and p, the probability of success, to be 50%, 0.5. Right, now the question asks to have 5 consecutive success. This means that x equal to 5. We need to find x equal to 5. So having n and p, we can plug it into a formula down here, and then we gonna get the answer. So the probability is about 3%. So there is a 3% chance that in 5 days in a row, we get a price increase each day. Practice problem. A student is taking a multiple choice exam in which each question has 4 choices. Assume that the student has no knowledge of the correct answers to any of the questions. She has decided on a strategy in which she makes 4 little pieces of paper marked A, B, C, and D for the multiple choice question, and then randomly selects one for each question. This is like an experiment that we want her to pick and answer a question, a multiple choice question, randomly with no knowledge about any of the choices. The marking on the piece of a paper selected will determine her answer to the question. There are 5 multiple choice questions on the exam. What is the probability that she will get A, 5 questions correct? So you have the formula here. So that's kind of imply that this is a binomial distribution. So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So first of all, why is this a binomial distribution? Each question that she answers randomly, picks A, B, C, or D, one of the choices. It's an experiment in which she's going to have 2 output, whether she's going to get the question correct or not, right? There is only these 2 possibilities. So, and also she's going to repeat this by doing another question, another question, another question, right? And this is going to happen 5 times because there are 5 questions in this exam. So if we define x as the number of questions answered correctly, then X is a binomial distribution. X follows a binomial distribution with n equal to 5 because there are 5 questions in the exam. And probability of success. What is the probability of success here? That means that she's going to get the choice correctly. So it is actually the likelihood of picking any of the 4 choices, A, B, C, D, is equal, we assume. So if she picks randomly any of the choices, the probability that she gets the question correct is 1 out of 4 because only one of the 4 choices is correct. So that's 25%, 1 out of 4, right? So the probability of success here is 25%. Okay, so now the question asks for what is the probability that she gets all of the 5 questions correct. It means that we are looking to find the probability that X is exactly equal to 5. So the probability that X is equal to 5 is, we're going to plug it in everything in the formula, and we're going to get 0.00098, which is a very small number. So the chances that she's going to get all of the 5 questions is almost 0, or very small number. Let's see the next part of this question. So she is taking a 5-question multiple choice exam, 4 choices for each question. What is the probability that she will get, part B, at least 1 question correctly? So please pause, work on this problem, and then come back to see the solution. All right, let's see the solution. So here we are looking for at least 1 question. We know that X, the number of choices, the number of questions that she gets correctly is still a binomial distribution with n equal to 5 and p equal to 0.25 probability of success. All right. So the question is asking for at least 1 question correctly. What does this mean? This means that the probability of X greater than or equal to 1, right? At least 1. It means 1 or 2 or 3 or 4 or 5, right? This is what it means. So it means that getting the 1 question correctly plus getting 2 questions correctly plus the probability that getting 3 questions correctly plus 4 questions correctly and 5 questions correctly. All right. So as you see here, we have to, for 5 different of these, we have to do computation for equal to 1, equal to 1, equal to 2, equal to 3, equal to 4, and equal to 5. So we have to plug in these numbers into the formula in this formula 5 times. But there is actually a simpler way to do that. The simpler way, the shortcut is actually the probability that X is greater than or equal to 1. We know that the summation of all the probabilities is equal to 1, right? The summation of the probability for X equal to I for all the I, meaning that I equal to 0, I equal to 1, 1, 2, 3, 4, 5, this is all equal to 1. So we can actually use the complement rule to find this. So instead of solving for probability of X greater than 1, we're going to find it 1 minus the probability that X is less than 1. And since we are working with the discrete numbers, less than 1 means only 0. So that means this is equal to 1 minus the probability that X is exactly 0. So now we only have to we have to plug in and solve it only for 1 value, that's 0. So we plug in for 0, X equal to 0, and we find it, and then we subtract that from 1 and we get our solution. So this is a very interesting and a smart way to solve this problem. So use this, the 1 minus the probability. Every time that you see that you have to do a lot of computation, try to see if the finding the complement, the 1 minus the probability of the complement of that actually would work better or faster. So let me write the formula here. If A is an event, the probability of the complement of, first of all, the complement of A is A complement, right? Then the probability of A complement, we know that is A probability of 1 minus the probability of A. So this is a simple formula that we have learned. The probability of A complement is 1 minus the probability of A. All right, so that's why we can use this to find this probability. So n is 5, x is 1, p is 25%. We write it this way: 1 minus the probability that x is equal to 0, and we plug in everything and we get the probability as 76%. So the probability that at least she gets at least one of the question correctly is 76%.